This video is on finding slope using the slope formula. It's lesson 44 in your book on pages 279 through 281. Now you guys really should be experts at slope by now. We all know slope is easy, slope is fun, slope is rise over run. But sometimes we don't have the graph, we just have 2 points. Now we could graph our 2 points and then count rise over run, but sometimes it's easier to just use a formula. And so here, if we have 2 points, so my first point would be x1, y1. My second point would be x2, y2. If I want to find the slope, I can use this formula right here. This is my slope formula. M equals y2 minus y1 over x2 minus x1. Now remember that slope and rate of change are the same thing. So we're just finding the difference in our dependent variables, which are usually our y's, divided by the difference in our independent variables, which are usually our x's. Now here's an example that needs to be in your notebook. We want to determine slope from these 2 points. So we have the first point 2, 4, and the second point 6, 6. Now it doesn't matter really which one is first and which one is second. You'll get the same slope. But I'm going to call this my first point. So 2 is going to be my x1, and 4 is going to be my y1. And then this will be my second point, so I've got x2, y2. Now to find my slope, I use my formula, y2 minus y1 over x2 minus x1. Now I know y2 is 6, and then I'm subtracting y1, which is 4, and I'm dividing that by x2, which is 6, minus x1, which is 2. And now I just have to simplify the top and bottom and then divide. So 6 minus 4 is 2, and 6 minus 2 is 4, so I have 2 over 4, and when I simplify that fraction, I get 1/2. So the slope between these 2 points, the slope of the line, is 1/2. Here's another example that needs to go in your notebook. We've got 2 points, -6, 5, and 3, -13. Now again, it really doesn't matter which point is first. And to show that, I'm going to say that this is going to be my first point. So I'm going to call this x1, y1. And then over here, I've got x2, y2. Now I'm going to use my slope formula, y2 minus y1 over x2 minus x1. y2 is 5 minus y1, which is -13. And we're dividing that by x2, which is -6, minus x1, which is 3. Whoops. Now when I subtract the top, 5 minus -13 is really 5 plus 13, because when you subtract a negative, you're really adding. So 5 plus 13 is 18. And in the denominator, -6 minus 3 is -9. So I have positive 18 divided by -9, which gives me a -2. So my slope between the points -6, 5 and 3, -13 is -2. Now I know that this doesn't have a rise over run, but I can always just put over 1 if I need to graph it. But my slope is really just -2. We also sometimes need to be able to determine slope from a table, and this needs to be in your notebook as well. So we have this table of x values and y values, and we need to determine the slope between these points. Now, if the table involves a linear function, the slope between any 2 points will be the same. So the slope between this first point here and the second point would be the same. The slope between the first point and the third point would be the same as the slope between the second point and the third point. So I can really pick any 2 points here to be my first point and my second point. So I'm going to say that my first point, x1, y1, is going to be 10, 0. So x1, y1. And I'm going to say that my second point, x2, y2, is going to be 40, -12. I can do that because each of these rows in this table correspond to a point on the graph with an x-coordinate and a y-coordinate. Now if I want to find the slope between these 2 points, I take y2 minus y1 over x2 minus x1. So I've got y2, which is -12, minus y1, which is 0, divided by x2, which is 40, x1, which is 10. So negative 12 minus 0, of course, gives me negative 12. And 40 minus 10 is 30. Now when I simplify that fraction, because they're both divisible by 6, I get negative 2 over 5. So my slope is negative 2/5, which means I would rise negative 2 and run 5. Sometimes we also need to be able to determine slope from a graph. Now there are two different ways we can do this. We can take the 2 points and say y2 minus y1 over x2 minus x1, and we will get the same as if we were to count. Now I'm going to do this one both ways. So I have 2 points here. I have negative 2, 7, so I'm going to call this my first point, x1, y1. And then I have 3, negative 3, so this is going to be my x2, y2. Now if I want to find the slope from the formula, I use y2 minus y1 over x2 minus x1. y2 is negative 3 minus y1, which is 7, divided by x2, which is positive 3, minus x1, which is negative 2. Negative 3 minus 7 is negative 10. 3 minus negative 2, which is really plus 2, is 5. And negative 10 divided by 5 is negative 2. So my slope would be negative 2. Now I can always go back to counting the rise over run on the graph. So if I wanted to do it that way, rise over run, I'm going from this point to this point. So when I'm counting, I always go from left to right. So my rise would be down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my rise would be negative 10 since I had to go down 10. And my run would be 1, 2, 3, 4, 5. So it would still be negative 10 over 5, which is still negative 2. That works out nicely, huh? Alright, now let's do another one. Now you can actually choose here. You can do the slope formula, or you can count using the points. I'm going to use the slope formula because that's what this lesson is about. So I've got y2 minus y1 over x2 minus x1. Now, if we were counting, we'd want to start with the point on the left and go to the point on the right. But since we're using the slope formula, we don't actually have to do that. So I'm going to do x1, y1 as 3, 5, and x2, y2 as 1, negative 5. Alright, so my y2 is negative 5, minus my y1, which is 5, over my x2, which is 1, minus my y1, which is 3. Now negative 5 minus 5 is negative 10, 1 minus 3 is negative 2, and when I divide those, I get a slope of positive 5, because a negative divided by negative is a positive. The reason that it works that way, and that we don't have to count, or that we don't have to use the left point as the first point and the right point as the second point, is because the differences between these two numbers are going to be the same. They might be opposite signs, but if you flip the sign on the top one, you'll also flip the sign on the bottom one. So either way, you'll still get the same slope, which in this case is 5. Alright, now we know that horizontal and vertical lines have special slopes, and again, this is an example that needs to go in your notebook. So if I want to find the slope of either of these lines, I would take y2 minus y1 over x2 minus x1. So I'm going to say this is x1, y1 right here, and x2, y2 right here. Right, so for this first graph, y2 minus y1 would be 4 minus 4, and x2 minus x1 would be 6 minus negative 6. Now 4 minus 4 is 0, and 6 minus negative 6 is 12. But it doesn't really matter what the bottom here is. 0 divided by anything is 0. So the slope of a horizontal line is 0, and that is always true. The slope of a horizontal line is 0. Now for this vertical line, we can again do y2 minus y1 over x2 minus x1. So I'm going to label this x1, y1, and this one x2, y2. So if I put that in my slope formula, I've got negative 5 minus 1 over 7 minus 7. Now notice here, 7 minus 7, my denominator equals 0. That does not work. You cannot divide by 0. So the slope of this vertical line is undefined. And that is true for all vertical lines. Their slope will always be undefined. Remember, the rate of change is the ratio that compares the change in one quantity with the change in another. The slope of the line is the rate of change of the line, or how does the y value change in respect to the x value. And here's our final example that needs to go in your notebook. It says, Alyssa used the second hand of the clock to record the time it took a train to travel the distance from her house to a friend's house. The second hand of the clock was at 12 seconds when she began timing, and at 38 seconds when the train had traveled 1/4 mile distance to her friend's house. What was the speed of the train in feet per second? So we're looking for speed, which is a rate of change. And speed is the distance per the amount of time. So to find the speed, we need to find the change in the distance and divide it by the change in time. Again, distance is our dependent variable. Time is our independent variable. So we know that, that the train traveled 1/4 of a mile, or 0.25 miles. So our change in distance is going to be 0.25 miles. And we're going to divide that by the change in time. So she started at 12 seconds and went to 38 seconds. So 38 minus 12 would be our change in time. That would give us 0.25 miles in 26 seconds. Now we wanted the speed of the train in feet per second. So now that we have a rate of change, we're actually going to have to convert that to feet. So I'm going to multiply that in conversion factor here, and I know that in 1 mile there are 5,280 feet. So my miles are going to cancel. And when I multiply 0.25 times 5,280, I get 1,320 feet divided by 26 seconds times 1, which is 26. Now, 1320 divided by is about 50.8. So the train's speed in feet per second is about 50.8 feet per